with this example, which should be the next one. We're looking for the empirical and molecular formula here for this guy. We give you some numbers. Phosphorus is like 39 something. Let's see here. Phosphorus is 3097. That's about right. And obviously our oxygen is still 16, has not changed. All right, so take a couple minutes here, calculate up the empirical molecular formula. Okay, let's take a look, see how we're doing here. So we're looking for both the empirical and molecular formula. So in this case, we take a quick peek at our percentages. We do have about 100%. So once again here, we could assume that we have 100 grams, which once again, we'll just turn those percentages into grams, same number. So that makes it easier. So that would give us 43.64 grams of phosphorus. Also would get us 56.36 grams of oxygen. Our normal step here to get to the empirical formula, we're going to divide by the molar mass of phosphorus, which is 3097 grams per mole from the periodic table. Also going to divide by molar mass of oxygen, which is 16 grams per mole. And that will get us some numberage here. That's going to go 4364 divided by 3097. And we'll go with 1.4091. Why not? Moles of phosphorus. 56.36 divided by 16, going to give us 3.5225 moles of oxygen. In this case, we always want to divide by the smallest number of moles, which in this case is the phosphorus. So we're going to divide them both by the moles of the phosphorus, giving us 1 for the phosphorus there and a 2.5, I think, for the oxygen. That means our empirical formula here is PO2.5. Problem with that is we cannot have a decimal, right? So this is a number that is, again, too far to round. So obviously you could probably imagine if you times that by 1, that's 2.5. If you times it by 2, that is 5. So we can multiply this empirical formula by a factor of 2 to get us to a whole number. We are going to multiply both of these guys by 2. And that would get us P2O5 as the proper empirical formula. Any questions on that there? Remember that we also want the molecular formula. So empirical formula we just got. We also need the molar mass of the empirical formula. So that would be 2 times 3097. Plus a 5 times 16 for the oxygens that are there. And that's going to give us a empirical formula molar mass of some type of number. About $1.41 here, 0.94 grams per mole. That's the second thing that we need. And in this case, we do have the molar mass given to us, which is typical in molecular formula problems. So once again, we're going to take the molar mass that was given to us, and we're going to divide it by the molar mass of our empirical formula, which was 141.94. And that is going to get us a number of about 2 here. By the way, it won't always be 2, it just happens to be in a couple of examples here. We're going to use that to multiply the empirical formula by, and that gives us a molecular formula P4O10 in this case. Any questions on any of those steps there? No. So I do want to show you an alternative solving a problem like this that you have two of the elements. With what's on the of each of the elements here, and we do have the molar mass of the actual compound, we could actually take the percentage of phosphorus and convert it into a decimal, which would be 0.4364. We then could times it by the molar mass of the compound here. And that basically will get us 0.4364 times 283.89. That would tell us that out of that 283 grams, 123.889 grams of it is the phosphorus. We could also do the same thing for the percentage of oxygen. We could convert it into a decimal. If I do my decimal right there, there you go. And we could times it by the molar mass here of the entire compound. And that will give us really the amount of grams there are of oxygen out of that 283, which in this case would be about 160 grams of oxygen. Now, what we could do with each of these is just take those grams and use the molar mass from the periodic table and convert them into moles. So this would be 3097 grams per mole of phosphorus. We'll take our 160 grams of oxygen divided by 16 grams per mole of oxygen. And if we do that, we will end up with 123.889 divided by 3097 is going to equal 4 for the phosphorus moles. And if we do our 160 divided by 16, will give us 10 moles of oxygen. What we just calculated is directly the molecular formula. So this would be the molecular formula, which would be our P4O10. And at this point, we know that the empirical formula should just be the simplest whole number ratio, which means we basically could reduce this guy down by dividing by 2, right? And that would get us to our empirical formula P2O5 by reducing this down by 2, basically. So that's an alternative approach that you could take to solve these problems. If you have the percent composition by mass of each element, you could actually go to the molecular formula first, and then basically just reduce it down to the whole number ratio, and you'll have your empirical formula. So either one should give you the same answer, just whichever way you want to go. You do usually need the percent composition of everybody to kind of go with this approach. Otherwise, you're doing a lot of calculations to get to the percent composition. But if it is given to you, sometimes people like to go this way and then reduce it down, so you can go an alternative approach. Any questions on how to calculate empirical formulas, molecular formulas? You are professional formula takers, yes? So we're going to wrap that up here for this chapter.